let's go to the test data page, and we'll press this tab that says test data. So let's enter the data for the first test point. So the suction temperature in this case is 26.25 degrees centigrade, and again we can select the various different units, but we're selecting centigrade for this temperature, and the suction pressure is 4.06 bar absolute. Again, we have two other pressure units that we could select, but we're going to select bar absolute. Now the inlet flow rate for this test point is 285.5 tons per hour. So we'll find that in the drop-down list and select that flow unit. Now for our discharge conditions. So the discharge temperature is 62.38 and it's degrees centigrade. So it's pre-selected by the unit that we selected above for the suction temperature. The design speed is the test speed is 2924 RPM, and then our discharge pressure is 6.035 bar absolute. Again, the pressure unit is selected by the suction temperature unit that we selected above here. So it's bar absolute. Now our composition. Now most likely the test composition will be different from our design composition. And again, if you have already defined your test gas, you can select it from the list. All right. So what we're going to do is redefine a test gas, and we're going to call it LGR test gas 1 because I already have a defined gas here, but I want to show you how to enter test gas for the test. But in addition, you could enter a different composition for each test point if you wish. All right, so in the same drill we had before, so we're going to select this manage and add composition. Okay, we're going to go up here, we're going to select add new, and we're going to give it a name. So we're going to call this LGR test gas 1. Okay, so now the components for this gas is nitrogen. We'll select that, double click, and then we'll enter in 1.4493 mole percent of nitrogen, and the other component is CO2, it's carbon dioxide, so we'll select that one, double click, and then we'll enter 98.5507 mole percent of CO2. So that is our test gas 1. And again, we'll press save and done. So now we need to select that from our list. So LGR test gas 1, so that's the gas for test data point 1. Now this button, register the new the test point, and see our test data entered below, and then we'll press plot test points, and it shows our test data point plotted with the design curve. So this test is obviously well out past the end of curve that we defined earlier. So it is probably, and which I know because we tested it at Stonewall. So that data point now is plotted. So we will continue in this same manner. We'll enter the data for test point 2. So we'll go back up here. So test point 2, then we have 26.94 degrees C for the suction temperature, and the suction pressure will be 3.94 bar absolute, and the flow then would be 249.5. Our discharge temperature is 67.74. 75. And the test speed is 2924. That still stays the same. And then our discharge pressure is 6.34, and we're going to keep the same composition, LGR test gas 2, so we don't make a change there, and we press register that data point, and we see point 2 below, so we can check to be sure that's all the data that we wanted, and then we can press plot data points again. So now the second data point now is plotted, and again the tags show up as we hover over each data point, and again on the design curve. And down here we can flow efficiency with respect to inlet flow. In the same drill, we can see all the data points and their tags that pop up. All right, so now let's enter data point 3. So the suction temperature is 25.92. Suction pressure is 3.79. And the flow rate now is 203.9. Our discharge temperature, 0.3, is 72.89. And the test speed is now 29.48. There's been a little adjustment in the speed during the test, which is not uncommon. Discharge pressure, which is 6.69. And then we're going to change gas. We're going to remake or redefine a new gas, and we'll call it LGR test gas 2. So we'll add manage again, and we'll go add a new test, and we'll call this LGR test gas 2. So let's enter nitrogen, because that was our first element. So we'll leave that the same as we had before. Well, excuse me, we do need to change it a little bit. 1.44. Okay, the original nitrogen was 1.4493. So we'll just make a very small change in the composition where it won't matter much on the test, but it'll demonstrate that we can enter a different composition for each test point. So now we need to get CO2, carbon dioxide, add that. Now we can see we have the difference from 100%. Okay, so now we know we need to enter 98.560 in order for that to be 100%. So this composition is essentially the same, but just a very small change, so it won't matter on the test, but it does demonstrate again that we can enter a different test gas for different points. So let's save that, and we're done. And then on this one, we'll select LGR test gas 2 right there. Okay, and then let's register that point. So now we have the third data point, and we can check the data to be sure that we've entered it correctly, and then press plot. And again, we see the third data point plotted. So now we're beginning to see where our test data is in relation to the design curve. So let's continue on with the fourth data point. So the suction temperature then is 25.53 degrees centigrade. Suction pressure is 3.73. And the inlet flow rate for test point 4 is 181.4. The discharge temperature is 75.38. Sorry, just reading my list here, make sure I got it right. 29.48. Okay, the speed stays the same, and the discharge pressure is 6.84. And then we're going to use LGR test gas 2. So that will stay the same, and we press register the data point, and we see our fourth data point. So we can check our data to be sure we're okay, and then we can plot it. And again, we see the fourth data point plots up here. So the tags also show which data point they are. All right, fifth data point. So this is our last data point. So on this particular test, there was only 5 data points taken. So in suction temperature is 25.45 degrees C. Suction pressure is 3.7 bar absolute. And the inlet flow for that last point, 131.8. And the discharge temperature is 80.31 degrees centigrade, and the speed is 29.37. A little adjustment in the speed. And then the discharge pressure of 7 bar absolute. And we're going to use LGR test gas 2. We'll leave that the same, and we'll register that data point. And again, you can check to be sure that we have all of the data correct and press plot the data points. So that has overlaid 5 of our test data points with the design curve, and we can see how they relate to one another. And then we can take this information back to the manufacturer if we don't agree with this test, and have a much more informative conversation with the manufacturer about the test results. Again, now this is a screening level, so it's not design, but it does give you an independent means to challenge your manufacturer's test data. Show the data report, so we'll press this button and we will see the data report, which at the top portion is the same that we had for our design, but as we scroll down we begin to see the compressor test data. So it gives us back all of the data that we entered during the test, and then this section gives us what the expected compressor performance would be recalculated to design conditions. So these are actually the points that were plotted against the design curve. And then it gives us the 2 gas compositions that we use, so we can keep track of that. So that concludes our test. So let's go back to the test page. We'll plot the data points again so we can see that. So we can, one thing we can do in the data points is we can edit a data point. So let's just say, for instance, this last data point we made a mistake. Well, rather than have to delete the data point and then re-enter it, we just press the little pencil, which gives us an edit, and it repopulates the data boxes with the information for that last data point, and we can make the correction here, whatever it may be. So let's say instead of it was the suction pressure wasn't 3.7, let's say it was 3.69. We can and then we go down here and press update the test point, and it makes that change, and then we can plot it. So doesn't make much change, but again shows you how you can edit a test point. So now you are armed with a means to challenge your manufacturer's test data independently, and you can write your own test report and see how that matches to the manufacturer's test report when you report to your engineering manager or your supervisor or the owner or the customer for your particular compressor.